You've learned all about displacement and distance, right? Well, there's a couple more aspects that are important to know: velocity and deceleration. To find the velocity, you take the displacement of the object, or how much the object has moved from point A to point B, and divide that by the time interval, or the change in time from point A to point B. This gives you the speed, but with direction, because velocity is a vector quantity. Acceleration uses time interval and the change in velocity, but we'll go more into that in a minute. Yet again, let's bring in the dog walker, Laurel. Let's pretend Laurel is walking at a constant speed with her dog Caius. In real life, it would be impossible for her to walk at the exact same speed, because of factors like the wind, terrain, slipperiness of the ground, if it rained, and even the pull of the dog she's walking. But let's assume she's walking at a perfectly uniform rate. It takes her 5 seconds to walk from the mini trampoline at the 6-meter mark to the second red pot at the -4 meter mark. This means we know her displacement. Her displacement was 10 meters left, because as you already learned, displacement is the final position minus the initial position. So -4 minus 6 is -10, which is 10 meters left. And we also know how long she walked for, 5 seconds. With these two pieces of information, we can determine her velocity. Average velocity equals the displacement, or the change in position, divided by the time interval, the change in time. So if we put in what we know, we'll have her displacement, -10 meters, divided by her time interval, 5 seconds. This gives us -2 meters per second. So her velocity is 2 meters per second left. That's the basics of finding velocity. But let's go a bit deeper. To find the change in velocity, in other words, how much an object speeds up or slows down, you subtract the initial velocity from the final velocity. And when you divide this change in velocity by the amount of time that's passed, you get acceleration. It might seem a bit confusing, but don't worry. I'll walk you through some examples. Now, I was curious as to how do you actually show acceleration in real life? Now, video games aren't real life at all, but I thought it'd be fun to try and show acceleration with Gran Turismo 5. I start off pretty well. 30 seconds into the race, I'm going 204 kilometers per hour. But I want to get further ahead, so I gradually speed up to 217 kilometers per hour without any interruptions. It takes me about 10 seconds to do this. What was my acceleration between those 2 points? In other words, how much did my velocity change in those 10 seconds? Take a look at the formula for acceleration. Acceleration is the change in velocity divided by the time interval, or the change in time. So let's put in what we know. In those 10 seconds, I increased my velocity from 204 kilometers per hour to 217 kilometers per hour. I also need to figure out my time interval. My initial time, when I first started monitoring my velocity, was 30 seconds into the game. My final time, when I stopped monitoring my velocity, was 40 seconds into the game. So my acceleration is 217 kilometers per hour minus 204 kilometers per hour divided by 40 seconds, my final time, minus 30 seconds, my initial time. 217 kilometers per hour minus 204 kilometers per hour makes 13 kilometers per hour. But wait, you can't use kilometers per hour with seconds, so right off the bat, I'll just tell you that 13 kilometers an hour is 3.6 meters a second. Now we can continue. Acceleration equals 3.6 meters a second divided by 10 seconds equals 0.4. So during those 10 seconds, my acceleration was increasing by 0.4 meters each second forward. I'll go through this next one a bit quicker. What you just saw was an example of positive acceleration. I sped up. In this next example, I'll show you negative acceleration. So here I am, driving along, 25 seconds into the race, and driving at 222 kilometers an hour. I get a bit overconfident. I suddenly pull the brakes, but too sharply, bringing me down to 92 kilometers an hour at about 28 seconds into the race. How much did I decelerate? Even though I'm slowing down, not speeding up, the acceleration formula still works. My acceleration will just be negative. From 25 seconds, my initial time, to 28 seconds, my final time, into the race, my velocity changed from 222 kilometers per hour to 92 kilometers per hour. I slowed down. 92 kilometers per hour minus 222 kilometers per hour is negative 130 kilometers per hour. But again, we need to change kilometers per hour to meters per second before we can use it, because we can't use both hours with seconds. Negative 130 kilometers per hour is negative 36 meters per second. 28 seconds minus 25 seconds is 3 seconds. Negative 36 divided by 3 is negative 12. So there we have it. I decelerated by 12 meters per second backward.